Hello, everyone. Good afternoon. Dear authors and invited guests, welcome to the technical session 6C. My name is Siddhi Avdi, and I'll be your session moderator for today's session. On the behalf of Global Knowledge Research Foundation and GR Scholastics, it is my great pleasure to welcome you all to the 9th International Conference on Smart Trends in Computing and Communication, SMARTCOM 2025. The ninth edition of the conference is being held in a hybrid mode. Physical event was held yesterday in Pune, and the virtual event is being held via Zoom meeting today and tomorrow. I hope you will enjoy this knowledgeable and interactive session throughout the day. In this session, in total we have 10 presentations. Each presenter will be given a 8-minute time span for the presentation and 2 minutes will be given for questions and answers. Now, on 7 minutes of your presentation, I will be raising a gentle reminder. There is another request to all the participants that you stay connected with us till the closing remarks. If you have any queries or update, then you can write it to me in the chat box. Now, just before we get started, I would like to introduce you all to the chair of today's session, Dr. B. Uma Maheshwari. Dr. Uma Maheshwari is an assistant professor in the Department of Computer Science and Engineering at JECRC, Jaipur, Rajasthan. She has 14 years of teaching experience and 2 years of technical expertise. Her skill set spans C, C++, Java, J2EE, .NET, and RPA technologies, with numerous certifications including machine learning and network security. She has published around 20 research papers, authored a book on operating systems, and 2 patents to her name. Welcome, ma'am, to today's session. Now we'll proceed to the very first presentation of today's session. So the very first title is Assessing the Potential of Blockchain Technology in Transforming Digital Identity Management Systems. And this paper title will be presented by Afia Anjum Abdul Rafiq from Datta Mege Institute of Higher Education and Research. I request Afia ma'am, if you're there in the meeting, please continue with your presentation.
Just speak to her. Just speak to her. Don't speak to her first. Then you
Introduce myself.
Yes. Hello, ma'am.
Hello, ma'am. Can I audible? Hello, ma'am. Can I audible?
Yes, ma'am, you're audible.
Okay.
Ma'am, are you going to present on behalf of Afia ma'am for this paper title?
No, I'm Afia.
Okay, because you have not joined with that name. Okay.
Okay. No, I joined with another.
No, I
ID.
joined with another ID.
That's all right, ma'am. You can start with your presentation. Try to wrap it up in 10 minutes, 8 minutes. I'll raise a reminder after 7 minutes.
Okay, ma'am.
I'll stop sharing my screen, then you may share your screen and start.
Okay, ma'am. Good afternoon, ma'am. My name is Afia Anjum. I'm from Datta Mege Institute of Higher Education and Research. And today's my research topic is assessing the potential of blockchain technology in transforming digital identity management system. And my co-authors are Martin and Dr. Shailesh sir, Dr. Deepak sir, and Dr. Pankaj Kumar sir. The table content of my research is introduction, research of methodology, problems, difficulties, blockchain application, and core function, advantages, and conclusion and references. Introduction. Today's digital economy should enable interaction more securely. Everything from e-commerce and social media platform to banking and healthcare service depends on identity system. On the contrary, traditional centralized identification systems have a number of severe flaws in design, such as lack of user control, inefficiency, and vulnerability to data breaches. As an example, with the high-profile personal data breaches of several million individuals recently, Equifax in 2017 produced a gap within our current models. Research methodology. Uh, this paper uses a secondary research approach to evaluate a potential application of blockchain technology for the modification of digital identity management system. Secondary research is the research and interpretation of a current material from credible sources, perhaps in the form of academic journals, corporate reports, white papers, or case studies. Problem and difficulties of blockchain technology, the current problem and digital identity management. Digital identification systems are centralized as single entity stores and manage a considerably large amount of sensitive data. There are two significant drawbacks to the centralization. As much as it makes user data easy to reach, it adds a single point of failure. The challenges which is faced in the blockchain technology is security, privacy, latency, and throughput restrictions, blockchain size, computing power limitation, storage equipment, scalability, and interoperability and standardization. Blockchain application of digital identity. Government identification system. The government can utilize blockchain technology to provide its citizen with a safe, unalterable digital identity. For example, Estonia's e-residency uses a blockchain technology to empower its citizen to digitally sign documents and manage their identity without accessing services. Financial service and KYC process. Financial institutions incur hundreds of billions of dollars on customer identity verification through the Know Your Customer process. Blockchain can make KYC non-intrusive to end user across the various institutions. They interact with thus improving users' privacy and eliminating duplicate verification process. Core function and advantages of blockchain technology. Decentralization has been one of the critical features of identity management based on blockchain. As identification data is centralized in a traditional system, blockchain technology enables the creation of a distributed network where no single identity possesses total control. Transparency and trust. Only by means of blockchain open architecture can all the members of a network confirm the validity of every one of their transactions. Every transaction is logged on an unchangeable public ledger that has been inaccessible from past modifications. The conclusion of my research is that this technology is supposed to offer a potential solution to all critical problems of data security, user control, and privacy. Thus, it can transfer the management of digital identity totally. Because this system is decentralized, people are more in control of their data. This demands little authority from any centers and lowers the chance of any data breaches. And these are the references of my research. Thank you, ma'am.
Thank you, ma'am, for your presentation. Are there any questions from session chair?
No, ma'am. Just
Okay, then we'll proceed to the next presenter.
okay.
So the next paper title is BI Model Deep Learning Architecture for Improved Detection of Seizures from EEG Signal. And this paper title will be presented by Sanila Yes from University of Kerala, India. Sanila ma'am, if you're there in the meeting, please proceed with your presentation.
Yes. Am I audible?
Yes, ma'am, you're audible.
Okay. I hope the presentation is also visible.
Just give me. Yes, it is visible.
Okay. So, good afternoon. My name is Sanila, and I am presenting here my paper Bimodal Deep Learning Architecture for Image Detection of Seizures from EEG Signal. This is the outline of the presentation. Among the various fields, healthcare needs much more importance because it is about the human anatomy, and the data analytics makes breakthroughs, and new researches are going on this area. One of the major area where we need some analytics is epilepsy, that is the disorder of brain, and it is captured through digital EEG through computer systems. This is the process of taking EEG signal from our scalp, and the output of the computer system will be like this. The upper image says the seizures or the brain activity is normal, and the second image shows a distortion that somehow means seizure. The objective of the work is to develop algorithm with the purpose of reducing the time delay during the classification of seizures, and also to reduce negative of manual feature engineering, that is manually interpreting the diseases, and to propose algorithm which effectively derives prominent features from the signals. Also, this work is to apply signal processing techniques like FFT so that the electronic signals will be much more significant. To enhance the provenance of the signal, there are only relevant samples are taken using special methods. These are the review of literatures, and this is the data set I have used for this work, that is CHB-MIT data set that are collected from children's or pediatric patients of 29, and this data set is pre-processed to get wherever the seizure occurs, the time of occurrence, and the number of signals. This is a work design of different methods employed. So in first method, the raw EEG data undergo windowing, and we are using a machine learning classification of ANN. In method 2, the ANN as well as deep learning like CNN is employed. In method 3, along with the CNN, a 2D CNN method is employed using bimodal deep learning classification. And in fourth method, the entire signal undergo through signal processing also. This is the methodology of EEG data processing. It is implemented in Python, and the first step is feature extraction. It is done through windowing. So the entire signals are cut off in between 2 seconds interval, and the features are extracted from these signals. So the observation of the signal processing is we will get a top K amplitude. That means high amplitude signals only we are collected from the window. The first method is analyzing it through ANN, that is already implemented by the researchers. So from that I start my work, and I employed a 3-layer ANN, and this ANN shows somehow a little bit accuracy. So I go for the deep learning, that is CNN, because from machine learning to deep learning, we are employing much more number of deep layers so that the classification will become much more accurate. So this is two-dimensional convolutional neural network. The two-dimensional means it will classify the features into top K amplitude as well as the selected features like kurtosis, etc. So this is the 2D CNN architecture in which features are extracted through convolution, and the fully connected deep layer will classify whether it is a seizure or not. This is the workflow diagram of the EEG data, where 3-level classifications, convolutions, and classifications are done at the dense layer. So the observation is from CNN and ANN, 2D CNN improvises to 85%. This is the next method, third method. Here, some augmentation method is also used. Augmentation means if we are finding high amplitude signal, we are giving extra stress on the correct candidates so that we are getting the accuracy much more clear. That is bidirectional LSTM. It will store the memory of what past data or past events happened, and we can give much more importance to the highest peak level signals. So this is the input. It will forward through front layer, dense layer, output, then it propagates back. That's why it is called a bidirectional LSTM. This is the architecture of LSTM. This is the method where 2D CNN, that is bimodal. Bimodal means once using 2D CNN and next is using by LSTM. That's why my title is known as Bimodal Deep Learning Architecture. So now the sixth final method, that is for improving accuracy, I am extra giving a spatial weight. Spatial weight is 0.8 for the most relevant signals and 0.2 for less signals, so that the accuracy becomes much more prominent. This is the spatial weight calculation, where 0.8 for threshold, above a threshold, and 0.2 for below the threshold. This is the architecture of my work by model architecture. Left side is 2D CNN and right side is by LSTM, and the output is taken as given here. So the output from by LSTM and the output from the 2D CNN is combined and classify whether it is a seizure or not. So the results shows that per patient, that means observation around the patient is the data collection. 8,000 patients data are there, and year of recording. This is the patient age, in which 51 to 60 ages are about 1,500 samples, and number of channels presented is in the right side. This is the amplitude. When we pass the seizure data through the computer system, the high amplitude waves are propagating like this. This is the montage of one patient, where the green color shows seizure. When we record it through computer image interaction, it records like this. This is a performance evaluation using accuracy precision recall. And this is the accuracy of my work when compared with the previous works. So it in ANN, it shows 98.5. And with the augmentation, it becomes 95.4. Then the last one, accuracy of my last work is 99.1. That is using BiLSTM along with the augmentation and attention mechanisms. So these are the output. That is each features when compared with the previous works. So the green color, that is the current work, and the comparison of accuracy will become 99 point. When compared with the previous methods, it shows high accuracy. This is the comparison of recall, and this is the final accuracy table, where the entire research literature review papers accuracy is compared. So the topmost is my current work, and it
Ma'am,
shows 99.8.
sorry for the interruption, but we are past the presentation time. Could you please get to the conclusion?
Yes. So this work employs the seizure data classification using deep learning methods, and two algorithms are combined, that is by LSTM and 2D CNN, and the improvement is much more than the previous work, that is 15.75% improvement. So this is the future direction. So it can implement this work on devices, so the patients will be previously escaped from further faults. Thank you. Thank you, ma'am.
Thank you, ma'am, for your presentation. Are there any questions?
Yes, I would like to ask from where you got the data set for this?
Ma'am, it is freely available public database CHB MIT, Massachusetts Institute of Technology. They provided the data set.
So you didn't collected the data set from real time. That is, you didn't
Yes,
collect
yes.
training
what-
data set only you got that.
Yes, yes, yes.
Okay. Okay, ma'am.
Thank you so much, ma'am.
Thank you, ma'am. Now we'll proceed to the next presenter.
Okay, thank you.
So the next presenter is Chakshu Gupta from Vivekananda Institute of Professional Studies, Technical Campus, India. And the paper title is Binary Classification of Mushroom Edibility Using Machine Learning Algorithms.
Yes, ma'am. Ma'am, I am audible.
Yes, sir, you're audible. You may start with your presentation now.
Ma'am, is my screen visible?
Yes, your screen is visible.
So my topic is binary classification of mushroom edibility using machine learning algorithms. So my name is Chakshu Gupta and the co-authors are Dharya Goel, Sarthak Bansal and Dr. Chitali Bomik. And the introduction is mushroom prediction is a very important task. It's a very critical task because there are certain species which are poisonous and which can cause serious health issues if misidentified. So we are solving this problem using machine learning, where we are categorizing the mushroom as edible and poisonous on the basis of the physical features. We are taking the physical features like cap shape, color, odor, and on the basis of this, we are predicting the mushrooms, whether it is poisonous or whether it is edible. So motivation basically lies on the phenomena that we have to ensure the public safety, reducing the risk of poisoning. And mainly the problem statement is that we have to predict that the mushroom is edible or poisonous. We are doing the binary classification here, in which we are categorizing it into two categories. So our main aim is to prevent the misclassification of health issues. So this is the diagram in which edible and poisonous mushroom has been categorized. And in the previous times, the mushroom classification is basically done on the expert knowledge and manual observation, which is very time consuming. But we have used the classification algorithms for classifying the mushrooms. Here we have certain challenges that we have to feature select, we have to data pre-process, and we have to model optimize. So this is the technological stack, software modules, software. We are using Jupyter Notebook here, and modules NumPy, SkyPy, Analysis. These are all the modules and libraries. So methodologies is these are all these steps. First is the data pre-processing, which is used for handling missing values and encoding categorical variables. And second is the feature selection, in which we are selecting the most accurate feature. In third one, we are doing the training, in which we are training the model, and then we are evaluating it, in which we are splitting the dataset into two categories, training and testing, and then we are doing it. And this is the approach step by step. And this is the conclusion. We have applied the 29 machine learning algorithms, and we have found that the random forest is giving the highest accuracy. Here we have used lazy classifier function, which is basically predicting on the 29 machine learning algorithms. So in this, the future scope is that we can use the hyperparameter optimization, Bayesian optimization in the future time, and we can use the deep learning exploration also, in which we can use the images of the mushrooms and then classify it. Here we are using the physical features, but in the future we can also use image-based mushroom classifications. And here are the two diagrams. The left hand side one is the pair plot and the right hand side is the correlation matrix. So right hand side correlation matrix, you can see different colors, red color, blue color. So red color यहाँ पर correlation matrix, it's very accurate to 1 and blue is very accurate to -1. So here it's different colors show different classes. And this is the conclusion. यहाँ पर random forest classifier is showing the highest accuracy 97%, and then this extra tree classifier, then XGB classifier, bagging classifier, and then LGB classifier. And these are the references. Thank you, ma'am.
Thank you, sir, for your presentation. Are there any questions or shall I proceed further?
How you calculated this F1 score and all? What is the basic algorithm you applied? And did you do any comparison with the other algorithms?
We basically यहाँ पर we have used the lazy predict function. Lazy predict function, what lazy predict function does, it takes all the 29 machine learning algorithms and then it go to the comparison of the accuracy F1 score, and then it has given a chart of all the things, and from that
Can
we
you
have done
show
the
the
conclusion.
parameters?
Yes.
Can you show the parameters? Based on which parameters you have made this? Your thing does not have any parameters, right?
We have used the physical parameters, the color, odor, the stems.
Yes, if you are using any physical parameters means you should show some comparison, right? These parameters, if I apply this algorithm, this will be the any table form of comparison.
Wait. I have to stop here my screen क्योंकि मेरे को फिर I have to show the another screen also क्योंकि उसमें there is a table. I have not included it in this.
Okay, while presentation, you need to show the comparison, everything, right? In the same. You cannot say I have it in some other thing. Okay, proceed. No issue.
Okay, then I'll proceed to the next presenter. So the next paper title is Crop Yield Estimation Using Machine Learning and Deep Learning. And this paper title will be presented by Pradnya Apte from Cummins College of Engineering for Women. I request Pradnya ma'am to please start with your presentation.
Am I audible?
Yes, ma'am, you are audible. You can start with your presentation. I will raise a reminder after 7 minutes.
Okay. So good afternoon. I'm glad to present a paper titled Crop Yield Estimation Using Machine Learning and Deep Learning. So agriculture remains the backbone of many economies, particularly in developing nations where food security and resource allocation depend heavily on accurate crop yield predictions. So traditional crop yield estimation methods rely on manual surveys and physical sampling, which are often time consuming, labor intensive, and prone to errors. So our goal is to review existing machine learning and deep learning models, discuss their advantages over conventional approaches, and analyze how they can be further improved to tackle challenges in agricultural forecasting. So the key objectives of the study were to summarize current techniques and data sets used for crop yield estimation, evaluate the role of machine learning and deep learning models in improving prediction accuracy, and to discuss challenges and propose further research directions. So reliable data is fundamental for any successful crop yield estimation model. Various remote sensing technologies provide valuable insights into crop health and growth. So we have focused on research using the following sources. The MODIS satellite and Sentinel-1 and 2 satellites that provide high-resolution optical and synthetic aperture radar imagery that capture vegetation characteristics over time. Unmanned aerial vehicle drones equipped with multispectral cameras that offer detailed insights at field scale, enabling real-time crop monitoring, and vegetation indices such as NDVI and synthetic aperture radar data that help quantify plant health, moisture levels, and biomass density. These, along with the use of ground truth data to validate model predictions, can enhance the accuracy of yield estimation by capturing multiple environmental and climatic growth factors. So, machine learning has significantly improved crop yield prediction through various algorithms. Random forest is a popular choice due to its ability to handle large data sets with multiple variables such as soil moisture, weather conditions, and vegetation indices. It reduces variance and improves stability in predictions. Support vector machines are effective in identifying complex relationships within yield data, but require careful parameter tuning and computational resources. K-nearest neighbors is a simple yet effective approach, though it struggles with high-dimensional datasets and large-scale applications. A study showed that random forest performs exceptionally well in integrating synthetic aperture radar data NDVI values, and meteorological data for yield prediction. These algorithms can also be combined in ensemble models to enhance predictive performance. But ML models struggle with long-term dependencies and nonlinear spatiotemporal patterns, which is where deep learning techniques provide an advantage. So deep learning models, unlike traditional machine learning, automatically extract meaningful features from raw data, making them ideal for analyzing complex remote sensing images. So some commonly used architectures include convolutional neural networks, recurrent neural networks, and LSTMs, and transformers that use self-attention mechanisms. Convolutional neural networks have proven to be highly effective for crop yield estimation, particularly in processing aerial and satellite images. By automatically detecting patterns in vegetation structure and growth stages, CNNs eliminate the need for manual feature engineering. So, studies have demonstrated that CNN based models can predict crop yield with up to an accuracy of 90% when trained on high resolution satellite images and field data. So, one such study compared standard CNNs with an attention enhanced CNN and found that the latter improved corn yield predictions by capturing more detailed and spectral features. CNNs have also been adapted into 3D architectures to incorporate spatial and temporal information simultaneously, improving prediction stability across different growth cycles. The ability of CNNs to extract relevant features makes them indispensable in modern precision agriculture. Uh, LSTMs, which are a part of recurrent neural networks, can capture long term dependencies in sequential data. So, this makes them particularly useful for analyzing time series agricultural data, such as crop growth across different seasons. By remembering past inputs, LSTMs can provide a more accurate yield prediction compared to traditional ML models. A CNN LSTM hybrid model applied to yield estimation reduced mean absolute percentage error from 36% to approximately 10%, demonstrating significant improvement in forecast prediction. Additionally, LSTMs have also been utilized for drought prediction and climate impact assessments, making them valuable tools in agricultural resilience planning. So, transformers, originally developed for natural language processing, have recently been applied to crop yield estimation due to their ability to process sequential data efficiently. Unlike RNNs and LSTMs, transformers use a self attention mechanism to analyze relationships across different time steps simultaneously, so improving performance in multi-temporal yield predictions. For example, a study showed that transformer-based models outperform LSTMs in analyzing unmanned aerial vehicle and satellite-based time series data. Their ability to capture global dependencies across different time frames enhances the accuracy of yield prediction. Also, pre-trained transformer models can be fine-tuned for specific crop types and regions, making them highly scalable and adjustable for various regions. So, integrating multiple data sources significantly enhances yield prediction accuracy. So, for example, combining Sentinel-1 synthetic aperture radar data with Sentinel-2 optical imagery has been shown to improve prediction accuracy, increasing R-square values from 65% to 81%. Multimodal approaches which integrate optical, synthetic aperture radar, and climate data provide a more comprehensive view of crop conditions. For example, fusing unmanned aerial vehicle multispectral images with meteorological data has improved wheat crop yield prediction by 20% in certain studies. Such hybrid approaches reduce errors caused by single source dependencies and ensure robustness in yield forecasting across different agricultural landscapes. So, despite significant progress, several challenges remain in crop yield estimation. First is data scarcity. High resolution satellite and unmanned aerial vehicle data are not consistently available for all regions. This affects model training. The second is high computational costs. So, deep learning models require significant processing power, which makes deployment difficult in resource limited settings, and generalization issues. So, models trained on one region may not generalize well to different climates or soil conditions. So, expanding open access data sets and using cloud computing could help mitigate these issues. So, several advancements can further enhance crop yield estimation models. So, transfer learning is one approach. Applying models trained on well documented regions to data scarce
Ma'am,
regions could improve global. Yeah.
ma'am, the presentation time is, we've passed the presentation time. Now, can we please get to the conclusion?
Yeah. So, these are the future directions. And so yeah, to conclude, machine learning and deep learning have significantly improved crop yield estimation by integrating remote sensing, multimodal data, and advanced neural networks. While challenges such as scarcity and computational costs remain, further research in transfer learning and multi-sensor data fusion can enhance the effectiveness of these models. So collaboration across disciplines and regions will be essential for the continued evolution of technology-driven agriculture. Yeah, that's it from my side. These are the references I used for the paper. That's it from my side.
Have you done the research only for a particular type of soil and a particular type of crop, or it is a generalized one?
Not for a particular soil type, but majorly the ones I studied, the crops majorly I studied were corn and wheat, and in some cases soybean.
Okay. For soybean and wheat only have done the thing.
Soybean, corn, and wheat.
Okay.
Soil type was general.
Have you made any table for these three?
I don't actually, that was part of a different paper, so this is only the literature review.
Okay.
For the actual implementation, it wasn't included in this.
So, is there any conclusion for a particular type of soil? What crop you can put?
No.
Okay, no issue.
Thank you, ma'am. Now we'll proceed to the next presenter. The next paper title is Emotional Intelligence Integration in Artificial Intelligence. And the paper title will be presented by Kasif Kumar from Datta Mega Institute of Higher Education and Research, India. Kasif sir, I request you to please start with your presentation.
Okay. Hello. Good morning, everyone. My name is Kasif Kamar, and I, along with my co-author Supriya ma'am, am delighted to present our research on emotional intelligence integration in artificial intelligence. Imagine, in this session, we will explore how AI can recognize, understand, and respond our to human emotion, bridging gap between human cognition and machine learning in with.
Sir,
And I
you
am
haven't
sharing my
presented any screen.
yes, I am presenting. So imagine an AI assistant that not only understands what you say, but also how you feel. What if AI could detect frustration, excitement, or sadness and respond accordingly? This is the promises of emotional intelligence in AI. Our presentation will cover these contents. So let's start. Emotional intelligence in AI. Emotional intelligence is a growing field in AI that adds human computer interactions. AI can mimic human emotions, improving user experience and acceptance in service oriented applications. Awareness of AI is increasing in organization, especially with AI integration and automation. AI skills are crucial for employees at all organizational levels due to changing roles and responsibilities in industries. Machines excels in logic rules, but understanding human emotions remains a challenge. Improving AI is crucial for competence in the new job era. Introduction. Emotional intelligence in integration in AI systems. Emotional intelligence is a crucial aspect of AI systems in enhancing human machine interactions. AI is defined as ability to recognize, understand, and manage emotions. AI and automation are revolutionizing our many jobs, making AI skills a crucial component of mobile world. AI is becoming mandatory in all organizations for employees training, machines are better equipped to solve problems involving a syllogistic reasoning, but addressing human emotions remains a challenge. Organizations are integrating AI to alter human machine communications. Emotional intelligence is essential for creating new AI systems that are more connected to users. Scientific studies show how machines can detect and interpret human emotions through interface like video and voice recognition. AI enhances the user experience and satisfaction by providing feedback and support related to AI system use. Emotional intelligence and its impact. AI can learn based on a student emotion, creating a more suitable environment for learning. Emotional intelligence AI can improve patient care by recognizing patient's emotional status. Aligning emotional intelligence with AI is challenging due to the alignment problem and the effective gap between understanding human emotions and AI's ability. An interdisciplinary approach is needed, drawing from psychology, cognitive science, and computer science to design AI systems with emotional processing capabilities. Incorporating emotional intelligence in AI can enhance human machine interfaces and establish meaningful interaction with the target audience. Further, the research and development are needed to address ethical questions and technical milestones for empathic AI. Advanced technology advancement in AI. Modern AI systems use multimodal emotion detection techniques like facial recognition, voice sentiment analysis, and text analysis. These techniques helps AI-powered customer service and chatbots identify customer frustration or satisfaction, enhances user experience. Multimodal approaches integrate multiple communication channel and data processing for better understanding and interaction. Combining multimodal approaches enhance AI's capability to perceive and respond correctly to human emotions. Facial expression capture immediate responses to emotions. Vocal tone show hidden sentiment. Textual analysis identifies emotional context in written language. The integration of AI in AI enhances machines' ability to recognize, understand, and to human emotions, fostering more natural interactions in diverse applications. Some of the literature reviews I mentioned in these tables, like example, Mind Valley, he researched AI designed to function as a therapist by sensing users' emotions through wearable devices, and his result is aims to offer personalized guidance on various life aspects, enhancing user well-being and reducing loneliness. Research methodology. The study uses both qualitative and quantitative method to evaluate integration of emotional intelligence AI into AI systems. The qualitative method involves user interviews, case studies to understand human emotional responses and their interaction with AI systems. Quantitative method include statistical evaluations and performance metric to provide measurable proof the effectiveness of an AI system. Qualitative approaches focus on gathering and analyzing non-numerical data to gain insight into potential emotional expressions, cultural differences, and user perceptions. Quantitative method use measurable data to evaluate the performance and reliability of AI systems. The first step is a qualitative literature review to look at works related to AI and its implications in AI. Collect real-world data from interaction in education, healthcare, and customer service domains. The review will classify outcomes in terms of theme, including the facility of AI on emotional learning, context, contribution of AI on improving effective commitment of services, and moral prospects of emotionally smart AI. The study will collect data on emotional intelligence in AI through surveys and interviews, analyze it quantitatively and qualitatively, address ethical concerns, and ensure reliability via triangulation and pilot testing. Some
Hello.
data. Yes.
Sir, we are past the presentation time. Could you please get to the conclusion?
Okay. Some of results and outcomes. This study aims to provide practical and theoretical solution for application of emotionally intelligent AI, emotional AI chatbots in this chatbox detect emotion like frustration or satisfaction, improving user experience. Healthcare in healthcare, emotional AI monitors patients' emotional states, adding in tailored interventions for anxiety, depression, or stress. Used in educational to analyze student emotions. And conclusion is AI is increasingly important in developing countries, particularly in technology, work environment, and social interactions. AI's integration into AI has a significant impact on technology by learning and understanding customer behavior in the digital age. AI is a significant advancement in human computer interactions. AI technology need to sense and understand the human emotion to respond and arrange efficient interactions. Real world impacts and improvement in user satisfaction and efficiency due to AI driven AI systems. AI crucial role in enhancing user experience and satisfaction across various sectors. Thank you.
Thank you, sir, for your presentation.
Have you done anything to capture the emotion?
Yes, by Python, some data sets are used like FER 2013 datasets from in which images and videos of facial expression level with corresponding emotions like happy, sad, angry. In
Are you
front
taking only from images or from live video you are capturing the
of
images?
images, live videos, text analysis, everything.
Okay. So what are the things you are comparing while capturing the text? If it is audio file, if it is video file, how you are doing the comparison?
It was already provided some predefined collection of data sets like frustration statements, normal statements by which AI analyze how is the mood of viewer, or asking by questions.
Okay, ma'am.
Okay, now I'll proceed to the next presenter. So the next paper title is Employee Churn Prediction Using Machine Learning and Classification Techniques. And this paper will be presented by Anup Vinod Pachkare from Tarna Engineering College, India. Anup sir, if you're there in the meeting, please proceed with your presentation.
Hello, ma'am. My screen is visible. I am audible.
Yes, sir, you're audible and we can see your screen.
Yes. Hello, everyone. Good afternoon. Thank you for giving this opportunity to me present the paper in your conference. Today, my name is Anup Vinod Pasgare. My co-author's name is Nalunke and Smita Deshmukh. So these are some of the contents we are taking in our presentation. The abstraction, introduction, literary survey, proposed systems are some of the machine learning algorithms we are using in the predicting to the employee churn prediction after the evaluation, how to evaluating the performance, experimental analysis, conclusion, and reference. So on the abstract. In the employee attribution, it's become the significance and challenges for the organization to particularly experience and skilled employee living to the better opportunity. This can be a result of substantial financial cost and due to the need of recruiting the and training of new staffs. To addressing this issue, the organization can be analyzed both and current and historical employees to data identify the common factor of the contribution to attrition. This prediction and preventing the employee turn over the various methods applying in a human resource data, including the decision tree, Adobe Boost algorithm, random forest, voting classification, stack classifier, KNN algorithm. These are by using these technologies, we are trying to fetch a selection of data and techniques to refine and improve the accuracy of prediction. And the next slide is the introduction and the why. What is employee employee churn? The
Sir, can you directly go to the proposed methodology?
proposed methodology.
Yes, methodology. You can
Yes.
explain this.
Yes, ma'am. This is the architecture of my project. Actually, when we have taken a data set from the IBM data set of the employees. These are the some of the 30 total features we are including in the features names. This is a sample of a data sets. We have taken a data from the IBM's HR. So this is the data set of that. So the first we have that at the data set, we are collecting the data from the raw data initially phase of the system module, evaluating collecting data of previous sources, including the public data set. This data is a raw and unstructured data. This is a module of scalable to selecting the specify the attribution of entity. Data set can be a source for IBM HR data and IBM analytics and Carly's responding. The second is the feature selection. In this, the feature selection, we have a collecting of often the imbalance of noising unstructured elements. It is a filtering and processing to the including cleaning of missing the values and converting format and the smooth numerical values. The input data reduce and migrate into the dimensionals and reducing the improve the system performance. The data mining is technique which used to addressing the consistent features and scaling the modification. The next step is the data processing. In the machine learning is a model are powerful tools to taking complex tasks and resolving the problems. This is a rapidly growth of a data and business across the industrial and increasing the adopting the modules. The highly quality of adopting cultures, we have training data set and carefully planning to manage the essential trailings of organization. The next step is data classification techniques. We are applying the different classification techniques in the my project. And I have mentioned in the PPTs also the Adobe Boost algorithms, KNN and random forest, SVM, stack flowing algorithms are we are using into that. After this applying this algorithm, we have get the performance evaluations in the project. After the analysis of employee evaluation turnover, the crucial addressing imbalance between the employees who are leave and who those are stay in accuracy of mislead to the turnover the rating below 50%. It additionally performs the metrics which are using to provide a comprehensive evaluation. In this case study, we have positively classing respected depreciating employees while the negative class and including those who are remain. The 5 evaluation metrics which can get performed to the supervised learning algorithms. These are the some of the Adobe Boost algorithm, KNN and random forest. And the Adobe Boost algorithm is in machine learning. I have explained some of these lines about these algorithms. The Adobe Boost algorithm is machine learning, which techniques is to combination of multiple weekend learnings to the create a strong predictive models. After that, KNN algorithm is used to the simply and machine learning to classify the pointing to measures of their their nearest nearest neighbors. Then the random forest is an essential method to building the multiple decision trees and combine with predicting and improve the accuracy of reducing the offer tip. Voting classification algorithms is the use for the combination of multiple modules like the such as the decision tree, SVMs, etc. to make the finalize the predictions. And the last one is the stacking imbalancing. The stacking imbalancing learning techniques is a multiple model called as an based of learning to train and make the predicting the meta models to those the combination of output. These are the evolution.
Directly go to the result part, sir. Show me the result table. Huh.
Yes. Ma'am, these are the results actually we have implementing after the performing these 5 algorithm. The accuracy of stacking algorithm is more other than the other three algorithms. In the graphs is also showing to the 84% of accuracy preventing to the this from this analysis. The next slide will be the conclusion. So can I go for the conclusion or?
Yes.
Yes. This employee retention is a crucial for the organization identifying both the attrition and retention costs for the helping to reduce the turnover. The machine learning is a technique effective the predicting to the factors. This research evaluation various classification algorithm using the Python analysis and correctly between the job satisfaction, salary, training, and jobs stability to the and other factors. These are the key influence of employee commitment, including the periodic and companies, the job security and promoting the policies, work-life balance, recognition, growth opportunities. These are the some in this our project. References, ma'am.
Okay.
Thank you, sir, for your presentation.
Thank you.
Now, are there any questions or should I proceed further?
Yes, you can proceed. No issue.
Thank you. Thank you.
Okay, so the next presenter we have here today is Dhruv Gidwani from International Institute of Information Technology, India. And the paper title is GPS-based toll tracking and speed monitoring system. Dhruv, sir, please start with your presentation.
Hello, am I audible?
Yes, sir, you are audible.
Okay. Is the screen visible?
Yes.
So, good afternoon. I'm glad to have this opportunity to present my paper, GPS-based toll tracking and speed monitoring system. The authors are Pranav Javade, Srushti Bonde, Dhruv Gidwani, Omkar Aher, and Dr. Bhavna Kanavde. So, talking about the scope of this project, the scope of this project lies to enhance and to give a convenience, transparency, and a good road safety. So this is a GPS-based toll tracking and speed monitoring system. So what it provides is automatic toll collection, real-time vehicle tracking, speed monitoring and compliances, cloud-based data management, user access and notification. Moving forward, this is the current scenario. What we see in current scenario is that the government requires to build infrastructures to collect tolls. Also, even though the rules mention that the vehicles need to pass the toll booth within 15 minutes or so, but what we see is there are still traffic congestion that happens in the areas of the toll booths. Also, what we see is the speed monitoring. As of now, what we have is only limited set of speed guns are implemented or planted at a specific distance. There is no real-time monitoring of the speed that takes place. So this is the current scenario, and what we are trying to we have tried to implement in our project is to overcome these challenges of the current scenario. So moving forward, so yeah, this is the solution that this project will bring up to. It will give economic efficiency. The government need not to build toll booths. This money can be used somewhere else or in a better way for the road safety itself. Also, what we see is that this project will give seamless traffic flow. The traffic congestion that takes place near the toll booths will not happen. The third thing will be speed monitoring. This is an important feature, I would say. The vehicle will be monitored in a specific time interval and in real time. So this is the architectural approach, I would say. So yeah, this is the vehicle. The live location of the vehicle will be stored on a cloud platform. What we are using here is a Firebase real-time database. So Firebase helps in tracking the vehicle in real time and also helps us in authentication. And this is a good security method, I would say. Then from here, the data is used in the backend, and what this data will be used for is to calculate the overspeeding and the toll charges. And then this data will be displayed in the front end, and the user can do the payment. And also we have the feature of giving him the notification. So algorithms, or I would say approach, what we are using here is a Haversine formula. Haversine formula will be used to calculate distance between 2 points, is used to calculate distance between 2 points on a spherical surface. And so this is the Haversine formula that we are using in our project. And for API, we are using Nominatum API. This is from OpenStreetMap. So this API will include the latitude, longitude, the name of the highways. So for example, here the name is Mumbai-Satara Highway. So the highway can be detected in with these keywords. Suppose the API has NH, MH, or it has a word highway written in it. So according to that, we will track whether the user is on highway or not. So talking about the results, this is our implementation. As of now, what we see is many vehicles, like many older vehicles, do not have the GPS technology inbuilt. So what we have built is an application. So when you when you log in through the application, the vehicle speed will be monitored, and this vehicle will be monitored in real time, like its latitude, longitude, its speed. All of this data will be sent to the backend through the application. So this is the application interface where we can see the latitude, longitude, the speed of the user. We have the stop tracking and login, logout functionality here. Moving forward, this is the dashboard where the user will be able to see his past history, or we could say, like, this will track his journey. Like this was recorded by our project member on 21st. So his history, like this history will be shown on the map. The red lines indicate that this is a non-highway road, and the blue line indicates that this is a highway road. And based on this, the distance traveled, and based on the distance traveled on the highway, the user will be charged for his travel. And during this travel journey, he will also be monitored for his speed. If he overspeeds, then accordingly the penalties will be added, and then the person will have to uh, pay for this charges. So coming to the conclusion, this research and this project will bring a significant improvement in toll collection, I would say. And also this is a important, or I would say a stronger or a robust system, because it uses Firebase as a platform. So this gives a good real-time tracking security, I would say. And also this would reduce cost related to the toll booths and enhance the road safety. Also the speed monitoring, or the accidents that occur. So all of this will be handled in a comprised and an impact system. So this is all about the project. These are the references that we have used for our project. And yeah, thank you.
Thank you, sir, for your presentation. Are there any questions, or should we go on to the next?
How you are collecting the toll amount?
Basically, ma'am, what we have is, as of now, we have 3 or 4 categories of vehicles, I would say, based on the two-wheelers, heavy vehicles, and uh, the four-wheelers, or we would say the two-wheelers are not included in this. Four-wheelers are included, heavy vehicles. And the heavy vehicles are again categorized into axes, like 6 axes or 7 8 axes. and based on this we have a different point, like suppose a 0.5 for a kilometer or 0.8 for a kilometer, and likewise.
So in your tracking system, it is showing how much distance covered, everything, but
Yes.
it is not showing what type of vehicle it is.
This data is taken during the sign up. When the user signs up, he has to register his vehicle in the system.
Okay.
Yeah.
So here, but you are not showing, na, this is type of vehicle. Then how you will charge that? How you send the bill to the, if he is over speeding, how you send the bill? What are the data that will be present in that bill?
Okay, ma'am. What I am trying to say is when the user signs up, so what we are asking for his data is his own data, personal, and also the vehicle's history. Like this, the vehicle will also be authorized. So based on the vehicle type, we are going to charge based on the distance traveled on the highway.
Okay, that I understood. Can you show me a screenshot like this for sending the receipt and for billing the person for over speeding?
Sorry, ma'am, I have not included this in
Okay.
presentation.
Now we'll go on to the next presenter. So the next paper title is Intrusion Detection Systems, Advanced Techniques for Network Security. And this paper will be presented by Akshay Kumar from Datta Meghe Institute of Higher Education and Research, India. Akshay sir, please start with your presentation.
Sure, ma'am. Hello, good afternoon, everyone. My name is Akshay Kumar. I am from the Tamil Institute of Higher Education and Research, and my paper title is Intrusion Detection System: Advanced Techniques for Network Security. And my co-author is Professor Sudhir Agarmole, Edidiong, and Kumar Gaurav, Nitish Kumar, and Aditya Mandal. And next, there is a content of our PPT is introduction, background, and importance of IDS, eh, machine learning techniques for IDS, deep learning for intrusion detection system, challenges and future directions, conclusion and references. And there is a startup presentation. There is an introduction. And research detection, sometimes called IDS, is a hardware and software product that monitor for detects possible intrusion, log information about them, attempt to block them, and send reports of the activity, security, and administration in a real environment. Intrusion detection could safety provide firewalls and other type of protection. IDS become important for defense because they monitor constantly analyzing patterns, suspicions, and then detecting ongoing attacks. And it is a security-based intrusion detection system are effective in detecting known threats, but are not certified at the identifying new or involving attacks. And there is it is a advanced cyber attacks now range of the advanced prestigious threats to zero-day exploit, stitching traditional security measures to a breaking point. Reviews recent trends in technology, intrusion detection system with a focus on machine learning and deep learning applied in this area. This paper reviews recently development development technology into detection focus on machine learning and sorry ma'am, these are the repeat the line. Sorry for this. And next point is the background and importance of the ideas. Intrusion detection system have undergone is a sea change since their introduction in 1980s. Invented is a simple
Sir, you
monitoring
can go
device.
to the machine learning slide of ideas.
Okay, ma'am. There is a machine learning techniques for ideas. The integration of machine learning into intrusion detection system has brought a sea change in a direction of cybersecurity threat. This ability to learn from historical attack data and identify deviation in normal behavior makes ML necessary tool in the current ideas frameworks. In a in intrusion detection, ML working in two phases, using supervised learning, and second one is unsupervised learning. In supervised learning, support vector machine and k nearest neighbors algorithm, and in unsupervised learning, k-means clustering and hierarchical clustering. And next is a deep learning intrusion detection system. Deep learning is a transformed way of the system deal with the complex network and cybersecurity threats. This is a very effective and finding whole set of localized pattern across the data in a network. For instance, of a specific form for network attacks. And next is the CNN has been filtered into the detection malware, phishing attempts, and folding attack by using a serious conventional layer followed by the pooling and fully connected layers. And RNN are fit for the temporal sequence of the network data, particularly the more powerful version of as a long short-term memory. And deep learning has a transformed data way of direction still with complex network thread. Oh, 1 minute, sorry. And this one is second slide of deep learning. LSTM for long-term dependencies, whereas Vinal's RNNs can model short-term dependencies. They often suffer from the vanish gradient problem, which is a struggle for the network to long-term dependency data. Use case in IDS, these LSTM based ISD models also identify various attacks ranging from the brute force attack and ransomware to insider threats. The crucial nature of a specific attacks, such as repeated login attempts in a brute force attack, or repeated access of sensitive files during insider threat, can be identified by the LSTM. One of the challenges RNN as LSTM computational complexity processing long sequence of the network data and computational extremely expensive, especially in a real-time environment. And there is a challenges and future direction. These are the challenges is scalability and zero day vulnerability detection and evaluation threat landscape. And these are the future research direction, uh, federal learning, expandable AI, and edge computing. And next is the conclusion. IDS, IDS remains very crucial in an effort to harden network security against the ever involving cyber threats. Traditional IDS approach, including signature-based and anomaly-based, has been foundational. However, these approaches have been grown to be restricted with increased sophistication, and especially when confronted with the complex attacks such as zero-day vulnerability. Machine learning, deep learning, and hybrid model in IDS framework have really improved to detection capabilities. These modern techniques hence enable various systems to identify unseen attacks, reduce false positive, and adapt to dynamic network environment. And next is a reference. These are the some reference to add our paper. Thank you.
Thank you, sir, for your presentation.
Sir, can you tell me any real-time scenario where you have implemented deep learning based ideas?
Ma'am, deep learning ideas like a deep, uh,
It's okay,
sorry,
sir.
sorry.
Okay, ma'am, proceed with the next.
Yes.
Thank you.
So the very next presenter is Aditya Shankar from SVKM's NMIMS University, India. And the paper title is Optimizing Airline Ticket Pricing, a Predictive Modeling Approach for Flight Fare Forecasting Using Machine Learning. Sir, if you are there in the meeting, please start with your presentation.
Hello, ma'am, is my screen visible?
Yes.
Hello. Yes. So good afternoon to everyone. First of all, I would like to thank SMARTCOM for providing me an opportunity to present my research paper here in this conference. So the title of my research paper is Optimizing Airline Ticket Pricing, for which we will be using a predictive modeling approach for the forecasting of the flight price ticket that will be there in future. So along with me, my co-authors are Ms. Koina Jadhav and Dr. Mayam Sohani sir, who was also the guide of our project. So introducing our project. So in the problem overview, we can say that the airline ticket pricing is a dynamic and very unpredictable thing, which is influenced by very different, we can say that factors like its demand, seasonality, pricing strategies. Also, if you're taking a flight which is from the source to destination, it is a direct flight or a flight which has multiple stops. And the key issue in this flight booking of the flight for consumers is that they struggle to book the flights for a favorable amount of price for the customers. Like the companies of the airline, they use different pricing strategies like discount traps are there for gaining the profits in this ticket pricing situation. So the objectives of a project is to provide a user-friendly system to guide the cost-effective bookings for the customers. Whereas we plan to build a machine learning model to predict those flight ticket prices based on different factors like dates of departure and arrival, source and destination, number of stops, airline type. Uh, so this was the literature survey that we did before writing our research paper. So we referred to different research papers on this particular topic, and we came to know that the existing systems that are there, which are working on this particular model, rely heavily on descriptive analysis rather than predictive modeling. So in terms of descriptive analytics means what they try to do is that they refer to the past historical data and just give the output based and give the output that is there. Like they don't use that past data to predict the what price will be there in future based on what prices are there in the future. So this is the thing that will be used by our model. And for this, we have used different models as for testing purposes, like random forest, gradient boosting, and many other models. And we also use different ensemble methods, which helped us in getting a good accuracy. And so, talking about the research gaps, we came to know that there is limited availability of real-time prediction systems for consumer use, which we plan to build. Also, there are very few papers which have explored the term of hyperparameter tuning, which is used to enhance the performance of a particular model. So this was the problem statement for our paper. Like we focused on reducing the we focused on reducing the problems faced by the customers when booking a particular flight ticket. So this fluctuation in flight fare is led to overpaying for customers due to lack of fare trend knowledge and airline pricing strategies like discount traps. And our goal is to build a system that empower users with with near accurate fare price predictions. So in our proposed solution, what we plan to do is we plan to develop, compare, and fine-tune machine learning models to predict this flight fares. We use models. We use performance metrics to evaluate models like mean absolute error, root mean squared error, and R squared method. And the best model that we found was a random forest regressor with hyperparameter tuning. So for this, this was our system architecture. Like when doing it, we first collected the data, then we pre-processed the data, then we did the feature engineering process, then model selection, like which model to use, then training that model, then evaluating it. In training model, we separated the data in two forms like training and testing data, and then we evaluated the model. Then we use prediction using a confusion matrix, and then the last thing is the user interface, like the application that will be built. Along with this is the sequence diagram, like what sequence will be followed. Like when the user searches for a particular flight, the system will fetch the database and search for the available flights. Then it will return the number of flights that are available to the user. Then the user will send the flight details, like at what date he wants, like at how many stops he needs, and his source destination and all. So based on this input, the database will return a predicted fare which will be displayed to the user. And this was the data flow diagram, like for the same, like search the flight, then process flight data, generate prediction, and display results. And the main thing was the flight database in this. So these were the models that we referred for our research paper, like linear regression, random forest regressor, decision tree regressor, XGBoost, SVM. Then we use hyperparameter tuning to enhance the accuracy with random forest regressor and XGBoost regressor. So as you can see that a random forest regressor initially gave us the best accuracy of 87.140, but whereas when we used it with hyperparameter tuning, it gave us even a slightly better accuracy of 87.381. Here's the comparative graph of the same. So the next, like why was random forest regressor with hyperparameter tuning the best model? So hyperparameter tuning generally involves the combination of parameters like number of trees, max depth, or minimum spheres per leaf. So which helps in maximizing the model's performance. So the random forest excelled due to some three major reasons. Like it helps in capturing nonlinear relationships. It reduces overfitting through ensemble learning approaches, and it also performs well with the noisy data. And in the end, I'd like to conclude with that our model will help in effective prediction in the for the future ticket prices of a particular flight. Also, there will be model advantages like capturing nonlinear data, reducing overfitting, which was helped due to the selection of random forest regress, which was there due to the selection of model of random forest regressor. And key contributions will be that it identifies the important fare factors, it compares multiple models, and is also a user-friendly approach for integration into booking systems. Whereas in future, we would like to incorporate the real-time pricing, and we would like to expand it into a multimodal travel, and also develop a consumer app which is more suitable for the consumer view. Like there will be a real-time dashboard and all the facilities for the consumer in future. So final takeaway from this was the model empowers travelers with data-driven, cost-effective booking prices and decisions, and improves fare prediction accuracy. These were the major references that we referred when writing this research paper. Thank you.
Where you got the data set?
Ma'am, actually, we referred to a Kaggle dataset, but this dataset was not like it
It
was
is
not
not
a
real time, no? Kaggle means
no, ma'am. it is not a real-time dataset, but in future we like currently we are working on including the real-time dataset as well.
Okay.
Thank you, sir, for your presentation. The very last paper title of today's session is Secure Voice Communication Using Cryptographic Algorithms. And this paper title will be presented by Ketan JP from PES University, India.
Hello, am I audible?
Yes, sir, you are audible.
All right. So good afternoon. So I'll be presenting a topic on the topic secure voice communication using cryptographic algorithms. The table of contents of my today's presentation is this. So first I'll be talking about introduction and motivation. Secure voice communication is a crucial aspect of modern communication systems. The motivation for secure voice communication using cryptographic algorithm is driven by the need to protect privacy and secure communication channels. So here, the sender side has an audio signal which we encrypt and is sent over a given channel. At the receiver side, we decrypt the audio signal, and the receiver gets the original message. So since the major focus of our research was on encryption and decryption, so we used four cryptographic algorithms. The four cryptographic algorithms are RSA, which is a standard algorithm. A modified RSA is what we make changes in it. 3DS is another algorithm, and 2T DEA. I'll be talking about each of the four cryptographic algorithms. First is the RSA algorithm. The standard algorithm, which is an asymmetric key cryptographic algorithm. Here it mainly relies on mathematical properties, which includes you use large prime numbers in order to generate a private key and a public
Your
key.
slide is not moving.
Sorry, the slide is not moving.
Yes,
Hello.
now it's showing methodology.
Now it's showing methodology. Is it visible now?
Yes, yes.
Okay. The methodology part. Okay. The RSA algorithm is asymmetric key algorithm. So we use large prime numbers in order to generate the private key and the public key for encryption and decryption. So in the modified RSA algorithm, we change it by increasing the key length and the number of rounds, the number of times we do encryption and decryption. The triple DS algorithm is when we apply the DS algorithm 3 times. So this enhances security as there is more encryption levels. The 2D DE algorithm is again an enhanced version of the triple DS algorithm, in which we change the number of rounds. The number of the key length also changes. So these are the four cryptographic algorithms on which we perform encryption and decryption. Apart from that, we have socket programming, which is used for transferring your audio signal from audio data from one user to another user. We use a client server architecture for socket programming. In the end, we also compare the results of all the four cryptographic algorithms. Like we compare it based on different parameters like number of rounds. Number of rounds represents the number of times you perform encryption, decryption. Block size represents the size of your data. So memory utilization, as the block size and the memory block size increases, the memory utilization also increases. Other parameters are like execution time and signal to noise ratio. The software implementation details are the algorithms. Apart from the four algorithms that we used, we have libraries like PyAudio, Base64. And then these are the reference papers that we used in order to complete our research paper. And that is it.
Have you compared the results of your paper?
Yes,
Can you explain this?
Yes, the rounds represents the number of times we perform encryption and decryption. As in the modified RSA, we do it 3 times. A simple RSA, just a simple one-time encryption is done. The block size represents the number of bits that your data is converted. The audio signal is when it's converted to your digital signal. So each block is going to have around 64 bits for a modified RSA. Similarly, for a 3DS, it's going to have 64 bits, but for a 2DS, it's going to be 128 bits, which makes it the larger the block size, it becomes more tough for any intruder to decrypt it. That is the idea behind it. Memory utilization is the amount of, since each cryptographic algorithm becomes more complex, the amount of memory it takes also increases. Execution time is the time taken to perform the entire encryption. And you have signal to noise ratio when that usually comes during transferring of data from one user to other user.
For the same data, yeah, does it require 48 rounds in case of 3DS?
Now that is again variable. We can reduce it or increase it, but we thought since we want to keep it.
Because block size would be the same, right? So this much variation is there.
But again, if you have more encryption, more number of rounds, it becomes
For
more
which
tough to decode.
application you performed the methodology and got this result?
On any audio signal, I'm like you took our phones, we recorded, or we can take any audio signal from the internet, and based on that we perform encryption and decryption.
Okay.
Thank you, sir, for your presentation. This was the last presentation of today's session. Now we'll proceed to the closing remarks. I sincerely thank our authors for their excellent presentations and contributions in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on the behalf of the whole team, thank you for the support during the 9th version and all the previous 8 versions of the conference. We will be happy to have you in the 10th version in 2026. All the presenters would be getting their digital certificates through email within 2 working days. Further, all the papers have already been forwarded to the Springer. Publication will be live within 6 months. Kindly cooperate with the team of SMARTCOM 2025. I also thank our session chair, Dr. Uma Maheshwari, for chairing this session.
Thank you so much, ma'am.
A token of appreciation to the chair on the behalf of Team SmartCon 2025 and Global Knowledge Research Foundation and partners. Thank you for your valuable presence. Now, just before we end this session, I would request all the participants to please switch on your cameras so that I can take a quick snapshot of today's virtual conference. We'll just wait for a minute so that everyone will turn on their cameras. Okay, so I've taken the snapshot now. We can end this session.